this section, we are going to look at 6-2 notes, which is complex numbers. And so, before we get into complex numbers, let's just review a little bit about simplifying radicals. And so, to simplify a radical, you might have something like the square root of 50. And you might be asked to simplify that. And so the idea with simplifying radicals is not to get a decimal approximation like you'll get if you type it into your calculator, but to break this down into smaller radicals, and one of those radicals being a perfect square. So if we remember our perfect squares, we have them 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, and so on. And so whenever we want to break down 50 we cannot take the square root of. It is not a perfect square over here. But we could rewrite this into the square root of 25 times 2. Now notice I did not break that down into the square root of 5 times 10. I did not break that down into the square root of 5 times 10. Now, it is true that both of these equal 50, but 5 is not a square root and 10 is not a square root, so you can't simplify this. However, 25 is a square root, so the square root of 25 would be 5, so it would get to come on the outside of the square root, and then that 2 would be left on the inside of the square root, like that. Now, whenever we're talking about complex numbers, what makes a number a complex number is that we have an I. And if you'll remember back to Math 3, we learned that the square root of -1 equals I. And so what we're really doing here, a lot of students want to revolt whenever they hear that we're talking about something that's called an imaginary number, because that just sounds like something made up and useless. But really, I, our imaginary number, is just a way of dealing with the square root of -1, because we're going to get into a lot of situations where we have negatives under the square root, and I allows us to do that. So, if we get something like this, the example 2, if we're asked to simplify the square root of -32 here. So for this problem, we've got -32. So when we break this down, we want to have -1 times, and then for 32, I could use 4 times 8, but there's a bigger number that will work. I could use 16 times 2. And it is always best whenever you're doing these problems to use the largest number that will go into these numbers here. So 16 times 2 would be best to use. If you use 4 times 8, then you're going to have to break 8 down after that. So whenever I do the square root of -1, we know it is I. So I is going to be on the outside here. The square root of 16 is 4. Typically write the 4 before the I. And then the 2 we cannot take the square root of, so it has to stay underneath the square root. So this is what will be our answer. This is our simplification for example 2. So let's start looking at some of the problems that you're going to have on your Delta Math assignment today. The first thing you're going to be asked to do is just to simplify some of these roots that have negatives underneath them. So when we're thinking about the number 48, we want to think about numbers that we could multiply to get 48. And the one that we want to use here is 2 times 49. So when we break this down, we'll have -1 times 49 times 2. And so the square root of negative 1 is I. The square root of 49 is 7. 2 we cannot take the square root of, so it has to stay underneath the square root. So this would be our simplest radical form for this particular expression here. Let's try another one. Now we have the square root of negative 125. So again, when we break this down, we're going to do the negative 1. And then for 125, I could multiply together 25 times 5. And 25 is a perfect square, so that will work nicely. The square root of negative 1 is I. The square root of 25 is 5. And then this 5 right here has to stay underneath the square root because we cannot take the square root of 5. So this would be our simplest radical form for this expression. Now, we're going to get into some more expressions that are a little bit more difficult to combine. So here, we've got to simplify each one of these radicals first, and then we want to see what we can combine. So the square root of 64 is just 8. And then negative 48, we can break down. It's going to be negative 1 times, we could use 6 and 8, but neither one of those are perfect squares here. So we've got to think of other numbers that go into 48. For some of these, you're going to get outside of your multiplication tables. 4 and 12 will work here, but as a general rule, if you're using the square root of 8 or the square root of 12, both of those will break down, so you want to use a bigger number. So if you do 48 divided by 16, you're going to get 3. So this will break down into 16 times 3. And so the square root of negative 1 is I. The square root of 16 is 4. And then 3 has to stay underneath the square root. So we would have plus 4I square root of 3. The square root of 25, of course, is just 5. And then for the square root of 75, we're going to have to break that down. So that would be negative 1 times 25 times 3. And so the square root of negative 1 is I. The square root of 25 is 5. And the 3 is going to have to stay underneath the square root. So we've got plus 5I square root of 3. Now, just like whenever you're in Math 1 and you're combining like terms for expressions, you have to combine like terms here as well. And so this 8 right here and this 5, we can put those together. So when we do that, we're going to get 13. And then we also have a 4I square root of 3 and a 5I square root of 3. And so since those both have an I and a square root of 3, we can combine those. And when we combine them like we would combine 4x plus 5x. It just gives us 9x. So the I and the square root of 3 does not change. When we're adding here, we're just going to have 9I square root of 3. And so we cannot combine the 13 and the 9 here because these are not like terms. This 9 has an I square root of 3 with it, so we're just going to have to leave our answer like this. All right, this problem is a little bit different because it includes a cube root right here. And so a few things about cube roots. Whenever you see a cube root, it means what number times itself 3 times equals whatever the number is under that cube root. Something you need to know, you can take the square root, the cube root of negative numbers. So whenever you are taking the square root of a negative number, you're going to get an I in the problem. But when you take the cube root of a negative number, that is not the case. So here, if we're thinking of 27, negative 3 times negative 3 times negative 3, if we multiplied that together, that would give us positive 9 times negative 3, and of course positive 9 times negative 3 is negative 27. So right here, the cube root of negative 27 is negative 3. So with cube roots, you will not have an I. Right here, I've got 3 times the square root of 9. There's multiplication right here, even though there's no symbol there. So when I take the square root of 9, I get 3, so that's 3 times 3. And then the square root of 1, of course, is just 1. So I've got 9 plus 1 minus 3, and so 10 minus 3 is going to give us 7. So we actually get a rational number here. We don't have an imaginary number in this particular case. Let's try another one. Okay, again, we have several that we have to break down here. Notice right here for this first one, the negative is only outside of the square root, so we do not, we're not going to have an I with this first term here. It's going to be negative 2. The square root of 36 is 6, but of course we have that negative right there, so we're going to get plus 6I here. The square root of 1 is 1. And the square root of negative 49 is going to be 7I there. So notice on these that all of your square roots disappear. You don't have any square roots left because the numbers that you had right here were perfect squares. Now, whenever we look at these, we can combine our like terms just like we would if we were in Math 1. So we have a negative 2 and a positive 1, and whenever we combine those, we're going to get negative 1, and then we've got 6I and 7I, and if we combine those together, we'll get plus 13I. You'll notice right here in the directions, it says to simplify the expression to A plus BI form. Whenever we have numbers that are given in complex numbers. Complex numbers are numbers that include both rational numbers, like the negative 1 here, and imaginary numbers, like the 13I. So for a complex number, typically we write the number first, and then we put the I part second. So this is how we would type in our answer for this one. Okay. Here's another one. We've got a cube root again for this one. So for this first term, we're going to have negative 4. For the next one, I'm going to put this negative 3 right here for right now, and it's going to be multiplied by the cube root of negative 125. Remember, for cube roots, we're never going to have i's because you can take the cube root of a negative number. And negative 5 times negative 5, right, well, times negative 5 is going to be 25 times negative 5, which of course is negative 125 there. So the cube root of negative 125 is negative 5. And then we have our square root of negative 25. And so the square root of 25 is 5. But we have that negative underneath, so we're going to have an I with that. So we've got negative 4 plus 15 plus 5I. And we can combine our negative 4 and our 15, and that is going to give us 11 plus 5I. All right, let's try another problem here. Here we've got more cube roots. Notice these numbers get a little bit larger. So certainly you are welcome to reach for your calculator for these. To do a cube root in your calculator, there is a way to do it. If you're using Desmos, there's a way to do it, or if you're using the TI-84. But one shortcut that I want to tell you is that with our radicals, if we're taking the b root of x to the a power, that is x to the a over b. These are rational exponents that hopefully you've learned about before. So if I have the cube root of 216, 216 doesn't have an exponent, but if it did, I'd put that 1 right there. So this is 216 to the 1/3 power. It's a little bit easier to type that into the calculator that way than to try to search for that cube root. So if you want a cube root, you would raise something to the 1/3 power. So for 216, hopefully this one's going to be a perfect cube, to the 1/3 power here, we're going to get 6. So we get 6 for this one. We'll have minus 3 times, because there's multiplication here. We have to do the cube root of negative 729. And so if we take negative 729 and we raise it to the 1/3 power, or if you want to do the cube root, you can, we're going to get negative 9. Remember, this is a cube root, so we're going to have negative 9. We're not going to have an I for this one. And then we've got plus 3 times, the square root of 49 is 7, but we have that negative, so we've got to have an I with that one. So we end up here with 6 plus 27 plus 21I. And 6 plus 27 here is going to give us 33 plus 21I, so that would be our answer for this problem. Alright, so we're going to look now at multiplying these complex numbers, so multiplying. And so whenever we're multiplying here, the general rule is you multiply the things under the square root together and the things that are not under the square root together. There is some exception. You do need to make sure that you get any negatives out from under the square root first. And really, especially in this situation, it's going to be a little bit easier if we just go ahead and simplify a little bit first. So first, I've got the square root of the negative here is going to be I. I cannot break down 10, so I'm just going to leave it as the square root of 10. Over here, I've got the 6, and 90 I can break down. I can break down 90 into 9 times 10, and 9, the square root of 9 is going to be 3, and I have to leave the 10 underneath the square root. And so, as I was saying before, once you have your negatives out, you can multiply together the things that are on the outside of the square root. So I've got 6 times 3 times I, and that's going to give me 18I. And then the terms that are on the inside of the square root can be multiplied together, because all of this is multiplication. So the square root of 10 times the square root of 10 is going to give us the square root of 100, or you could think square root of 10 times square root of 10 is square root of 10 squared, so you could cancel that out. So the square root of 100, of course, is 10. So for this problem, we end up with 180I. Now, on this particular problem, everything combined down together. Let's look at another problem. All right. Here, we've got 8 square root of negative 84 times 5 square root of negative 7. And so for this problem, we need to break down that 84. So the square root of 84, we know we're going to have a negative 1. And feel free to reach for your calculator here. 84 will definitely divide by 4. That would give us 21. Let's see if it will divide by 16. It does not divide by 16. So let's do 4 times 21. And so that would give us the square root of negative 1 is I, the square root of 4 is 2, and the 21 has to stay underneath the square root. So I'm going to replace, this was what I was doing over here. So I'm going to have 8 times 2i times the square root of 21. And then over here, 7 won't break down, but I can take this negative and pull it out as an I. So I've got 5i square root of 7 here. So now once we've done this, everything on the outside of the square root can be multiplied together. So we've got 8, 2i, and 5i. And so we can multiply the numbers together, 8 times 2 times 5. And when we do that, 8 times 2 times 5 is going to give us 80. And then I times I is I squared. All right. We can also multiply the radicands, or the numbers under the square roots, together. And 21 times 7 is 147. So we've got the square root of 147. Now let's think here for a second about this I squared. We said earlier that I is just a way of us dealing with the square root of -1. So I'm going to replace the I with the square root of -1. So we're doing the square root of -1 squared. And when we square a square root, those cancel each other out, and we're left just with the radicand, what's underneath the square root, which is -1. So this is important to know. I squared, which we're going to see show up a lot, equals -1. So what we have here is we've got 80 times -1. And then 147 is going to break down for us. I believe that's divisible by 49. And sometimes you got to play around with these numbers a little bit. They might not pop up to you quite as quickly. But 49 times 3 does give you 147. And so 80 times -1, of course, is -80. And that's going to be multiplied by the square root of 49, which is 7. And then the 3 has to stay underneath the square root. So down for the end of this, we've got -560 square root of 3. And this would be our fully simplified version of our answer. Let's try one more of these. I think these are more difficult than the adding and subtracting. So here we've got another problem, and I've got the square root of -72. The square root of -72 will break down, and I could break it down into 36 times 2, so I would have -1 times 36 times 2. And so the square root of -1 is I, the square root of 36 is 6, and then the 2 right here would stay under the square root. So I would have 4 times 6i square root of 2, because we just broke down that -72 there. Then that would be multiplied by my -4, and then the square root of 64 is 8, but because we have that negative with it, we need to have 8i. And so we've got to multiply all this stuff that's on the outside of the square root together. You can think about reordering this. It's 4 times 6i times -4 times 8i times the square root of 2. Or you could even, reorder, because this is 6 times I, this is 6 times 8. So 4 times 6 times -4 times 8 times I square root of 2. Of course, you do not have to show either one of those steps there. I'm just sort of going through the reasoning behind it. So 4 times 6 times -4 times 8 is going to give you -768. And then I times I is I squared. That square root just has to stay right there. And so remember from the last problem, or the one before that, I squared, what was the last problem? Has to equal a -1. So this is right here, -768 times -1 times the square root of 2. Of course, -768 times -1 is going to be positive 768 times the square root of 2. And so this would be your answer for that problem. In our meeting tomorrow, we're going to look a little bit more at complex numbers, and look at a few more ways that we can multiply them. But this will cover what you need for your assignment today.